Hey, I hope no one's sick of hearing about chain abstraction yet, because it's been a few hours. We're going to keep going.
Yeah, we'll talk about chain abstraction in a new light, according to Bitcoin and Bitcoin L2s.
So just to introduce myself quickly, hi, I'm David. I run the emerging technologies team in Pagoda, and we're really focusing on chain signatures, which is the ability to put signatures inside of a smart contract.
All right, I'll do the same. I'm Munib. I'm the co-creator of Stacks, which is a Bitcoin L2, and we've been building in the Bitcoin ecosystem over the last 4 or 5 years. And I think recently, especially with the launch of Ordinals last year, you've seen a ton of developer activity coming back to Bitcoin, both to the L1 and to some of those new layers like the L2s that are launching. So it's a pretty exciting time to be building in Bitcoin right now.
So I'm going to jump right in and just sort of explain what Pagoda is doing inside the chain abstraction space. Now, chain abstraction, you've heard a lot about it, and it's all about people not caring about where they're doing the things they're doing. What we're doing is we're building a suite of technologies that makes that super easy, and I'm really going to dive into the technologies now. The most important one is something called chain signatures, and chain signatures is the ability to hold a secret inside of a smart contract. What this allows you to do is when you sign into a Near account, which is terrifically easy using stuff like FastAuth, you have the ability to encrypt stuff and to sign stuff. Now, all smart contracts is code you can't tamper with. And all chain signatures is keys you can't tamper with. And this allows you to promise that you'll do certain things with keys, which sounds very boring, but actually allows a huge set of new use cases. So for example, if you have an NFT that holds a key inside of it, you can exchange those NFTs very easily. So you could have one key that holds a large amount of Ethereum, and another key that holds Bitcoin, and you can swap the NFTs that hold those keys on the Near blockchain and effectively trade Ethereum and Bitcoin instantly without any transaction fees on either chain. Another thing we can do with it is once you're signed in, we can trust that you're not going to drain our faucet of Ethereum. So we can fund your Ethereum transaction before you do any payments without you having to understand that you are in fact transacting on Ethereum. So you could pay in USDC on Near and do a transaction in Ethereum. And the reason this is important in Bitcoin is that, first of all, Bitcoin keys are terrifically hard to hold. It's terrifically hard to onboard. And stuff like Ordinals is actually very, very inaccessible unless you already hold Bitcoin. So what we want to do for Bitcoin is allow people to have easy to access gas, easy to hold keys, and easy onboarding altogether.
Awesome. Actually, can I ask you a question?
Sure.
All right. Could you dive a little bit deeper into, I think we were having a conversation backstage about MPC and how you're using that to actually control the access and the smart contracts. I would love to learn more.
Sure, of course. Each smart contract in the Near blockchain holds a private key inside of it. The way we do that, so holding a private key inside of a smart contract is terrifically easy, but keeping it secret is much harder. So what we do is every single node, we have nodes on the Near blockchain, and they watch as the transactions go along. Now, if the smart contract calls a special method, those nodes, each of which have a key share, will start a protocol and generate a signature for that key. So it's super secure. The key is spread across a bunch of different nodes, and the user can use it the same way they program a smart contract, which is just calling a single system call. And then you have the ability to sign any arbitrary Bitcoin, Ethereum. We have Dogecoin working at the moment, and then you can have smart contract controlled external accounts on any chain you want.
Is it correct for me to almost as a user imagine that I have some sort of a access control, let's call it my Google Auth token or something like that, and the Near validator nodes are collaborating with each other to actually store my private key? I don't have the private key. In some ways, the Near validators have it on my behalf, and these validators need to collaborate with each other to produce signatures. But they will do it only if I ask them to, and they're not going to do it on their own.
That's exactly right. If you have, say, an OAuth token from Google, you can prove you hold that OAuth token to the Near network. Once you prove that correctly, the nodes will know you are who you say you are, and then from there you have access to your Bitcoin key or your Ethereum key. And what this does is, whilst preserving privacy, gives you the ability to do anything you like with your Bitcoin account without having to memorize a seed phrase or even really understand that you're using the Bitcoin network to control your ordinals or your NFTs or anything like that.
All right. And is the security model that this is honest majority, or is the model that this is enforced at the consensus level? Like it would be a consensus failure if they try to do something else.
So it's honest supermajority. So if there is an honest supermajority, you get to retain your keys. And we have some economics which we've designed called the NARC protocol, which is a form of identifiable abort. And what happens is it gives you the ability to do quadratic staking of any assets you hold. So conceptually, if you have 10 validators and each validator holds 1 Bitcoin, it would seem that you'd only be able to secure 10 Bitcoin worth of value. But using our identifiable abort system, any individual who is collaborating to behave badly can go on chain and explain what's happening and slash all the other nodes. And what this means is if someone asks me in to collaborate to try and steal some assets, I can turn around and take all of their stake away, meaning that economically it doesn't make sense for me to collaborate to take away people's assets.
So you can effectively punish all of the participants of the honest majority.
Dishonest.
Because to take the action, they were the majority, right?
Exactly. Anyone who's you can take action against anyone dishonest before they've done any harm, and it leads to this very sort of interesting game theoretical problem where someone comes to you and says, "Hey, I want to rob someone, but you can trust me," because you have to trust anyone you collaborate with to do bad things, which leads to very tricky situations.
Awesome.
Yeah, and I'd love to hear about what you guys are doing on Stacks with your new Nakamoto release.
Yeah, so I think I'll give everyone a little bit of background on the work that we've been doing. Basically, think of this as Bitcoin is the sort of like the OG chain, right? Like it's in the last cycle or even the one before it, sort of established itself as a store of value, as digital gold. But developers aren't like building like a lot of things on Bitcoin. Still, it's north of $1 trillion of capital. It's the largest brand name, largest community, largest number of users as well. So a small group of developers in Bitcoin, including us, have been trying to figure out that how do we make Bitcoin more programmable? How do we make Bitcoin sort of like scale out as potentially hundreds of millions of users are going to come to Bitcoin, because they wouldn't be able to use Bitcoin on the L1 level. Like Bitcoin is very, very hard to change by design almost, right? So the same properties that make Bitcoin valuable. Bitcoin is valuable because people know that it's not going to change. It's very durable, right? Like it's not like there are crazy consensus upgrades happening or someone is going to change the supply. Like one fun fact is that I can actually download a Bitcoin software all the way from 2013, so almost like 11 years from now, and run it, and it will still boot up to the current version of the block, which is an amazing property to have, right? Like imagine even on the second largest network like Ethereum, you can't even imagine it. Ethereum has gone from proof of work to proof of stake to maybe some other large changes happening. So these networks are much more experimental than Bitcoin. But the flip side of that is if you have something that durable and something that is very, very resistant to change, then how do you sort of innovate on it? How do you scale it? How do you bring new applications to it? So that challenge effectively, we've taken it over in what we call Bitcoin L2s. And there are different definitions of it. We can slice and dice them. What really is an L2, what is not. The definition that I follow is that most normal users, they think of anything built on top of Bitcoin as an L2, right? And then you can sort of classify them like how trustless they are or not. But at a high level, what I would encourage people to do is like think of Bitcoin, the asset, meaning BTC, separate from Bitcoin, the rails, like the technology, the network that it runs on. So we can upgrade the rails, meaning we can have built different types of L2s. Stacks is building one. There are a bunch of like other L2s that are launching as well. And your BTC can go from the L1 to the L2, where it's cheaper and faster, and you can use it there, right? And obviously it comes with certain trade-offs. Like when for example, with Stacks, the way the security works, and that's why I was asking about honest majority. So that's a similar type of a security model. When you take your BTC from L1 to L2, you're now trusting these Stacks validators that a honest majority of these people would allow for my withdrawal of Bitcoin from L2 back to the L1, right? But we could probably do better than that. There are some new sort of like projects and breakthroughs happening. One of them is BitVM, which enables basically much less trust in this L1 to L2 movement. instead of an honest majority, you just need one honest party in your set, which is actually a pretty big jump in terms of like reducing the amount of trust assumptions that are going on. So I think what a user experience looks like is like, imagine if I'm doing a Bitcoin L1 transaction and you're doing a L2 transaction after the Nakamoto release. On Bitcoin, I will have to wait something like, 10 to 40 minutes for a confirmation. And with a ton of traffic and ordinals, which are these Bitcoin NFTs, Bitcoin fees are going up a lot as well, right? So I might be paying like $40 to $100 in fees for doing my L1 transaction, which is slow, like 10 to 40 minutes to even wait for a single confirmation. But on the L2, on Stacks Nakamoto, you'll get like 5 second or whatever the initial block time might be, like the actual one. You'll get a confirmation. It's cheap, it's fast, and as soon as a Bitcoin block arrives, all of the L2 blocks settle on Bitcoin with 100% of Bitcoin finality. What that means is, like in terms of security, at the L1, what we care about is reorg protection, meaning that once a Bitcoin transaction gets in, how much sort of like, hash power or economic power would it take for someone to reverse that transaction or reorg the block? The way we have designed the Nakamoto L2 is it's the exact same thing once a Bitcoin block arrives. So to reorg any L2 transaction, someone will have to attack the L1 and reorg the L1, which is a pretty nice property to have. So now you have fast and cheap transactions on the L2, but the security property is basically 100% of Bitcoin finality when a Bitcoin block arrives. So the way we see this is Bitcoin L1 can remain what it is, but the L2 can keep upgrading, can keep becoming faster, can keep having more network capacity, can keep onboarding more and more users, maybe 1 billion users at some point, and we can still benefit from Bitcoin L1 security. So that's sort of like the vision that we think that Bitcoin is never going to scale to 1 billion users this way, but with L2s, they will be the default way that new users are going to experience like BTC transactions. Because at the end of the day, users don't really care, in their wallet, what they care about is like, is it cheap? Is it fast? Is it sort of like secure enough? And obviously it will become more secure with BitVM and some of the other things that are launching.
Well, what do you think the biggest challenges are when sort of getting people into that sort of Stacks and Bitcoin ecosystem?
I think basically I would say there are two types of challenges. One is that there are the existing crypto native users. And the way historically things work is, so I considered like the time between 2017 and let's call it 2022 as quote unquote dark ages of Bitcoin. Like there was a lot of like, even in like innovation or dev activity in Bitcoin pre-2017, this is like pre-Ethereum. Colored coins were invented on Bitcoin, NFTs, counterparty was invented on Bitcoin, stable coins started on Bitcoin with OmniLayer. But a lot of sort of like that intellectual capital and dev sort of like mindshare moved to Ethereum and then other chains like Near, Solana, Avalanche later on. So Bitcoin became like sort of like this, like dead town in a way. So the crypto native people that currently are in the industry, they're more used to using other networks, right? And the UX is better on those other networks as well. And I think they're slowly sort of like rediscovering Bitcoin. So if you go and look at the Ordinals community, they're getting a lot of users, they're getting a lot of trading volumes, like Ordinals trade as much as like ETH or Solana NFTs, for example, but the UX is still pretty bad, right? Like it's slow, it's sort of like, pretty expensive. So that's one part, like the industry rediscovering Bitcoin. And then the second part is the new users, like what we are all looking towards. So I think because Bitcoin L2s, like stable, high quality L2s don't exist today. Like I know Lightning has been around, it has its own internal routing and liquidity issues. Stacks has been around, but it's been slow like Bitcoin, doesn't have a lot of network capacity. So I think the next generation of L2s like Stacks Nakamoto and some of the newer ones that are being built and some upgrades to Lightning through Lightspark and others, I think when people start having a really good L2 experience, and that's their first onboarding to Bitcoin versus Bitcoin L1, I think that's going to be a massive difference because I think it's a night and day difference between the UX.
Our feeling with chain abstraction is there's a huge number of Bitcoin L2s out there. They all have sort of varying strengths. And users shouldn't be making a decision about which one they're using. They should use the application the way the application developer meant for it to be used without thinking about it too much. And I think a real strength of what we're doing here is that we can send users to Stacks without them needing to get a Stacks token or understand it. And they can be in the best place for Bitcoin smart contracts, which is maybe not near because we're not sort of, running on the Bitcoin consensus layer. We're not running with the same guarantees. And we don't have, necessarily such a good name with the Bitcoin community. So can you see any ways that we could work together and any interesting things we could build there?
Yeah, absolutely. So I think one model that I tell, other ecosystems like Near or others is that whenever you're thinking of stacks, you should think of stacks as the middleware to Bitcoin L1, right? Because Bitcoin L1 has a very limited, scripting language, and Stacks has a pretty expressive scripting language, which, by the way, we were talking about how often Nakamoto, Stacks is upgrading to WASM as well. So Near runs on WASM, Stacks is going to run on WASM as well. It will make developers' lives really easy if they want to do any cross-chain stuff and so on. But if you think of that as a middleware that is more expressive, like pretty much anything that you want to do, you can do it. And then we are focused on Bitcoin security or Bitcoin sort of like, trustless bridges, like especially with BitVM and others. Then you leave that work to the people who are sort of like specializing in that work. And Stacks becomes like a gateway or middleware to everything else. If you want to go connect to Solana, connect to Near, sort of like take BTC, like Stacks would focus more on like bringing Bitcoin liquidity from the L1 to the L2, and then you can connect to that liquidity or take it to Near or other places.
I'm really excited for in the not too distant future when we can compile a smart contract, deploy it on Near, deploy it on Stacks, and have the Near contract talking to the Stacks half of the contract, and having sort of a coherent application that really does span lots of different chains without thinking about it too much.
Yep, that's exactly what I'm excited about. And I think one way to think about this is the Bitcoin L1 is so limited by design that doing that exact thing with the L1 would have been extremely hard, if not impossible, right? So the role that Stacks L2 is over playing is that we have figured out how to build like a good L2, and that's a great interface to have with something like Near.
Well, thanks so much for your time. It's great to learn about how Stacks works.
Awesome. Great to be here.